Welcome to JS2. We are going to see a new topic which is called lineament density. By using ArcGIS ArcMap, we are going to analyze lineament mapping and lineament density. Lineaments are basically structures or controlled linear or curvilinear features which are identified from the satellite imageries or the digital elevation model or the DA. So first, let us open ArcMap and add the required data. If lineaments are structures or linear and curvilinear features, so this lineament density means that where the points or the lines concentrated within a given area or within a given study area. So the required data is the DM and the shapefile of the study area as well. So let's add the DM data. So this is the DM data. Let me add. So this is the DM data, and let me add the shapefiles. So zoom to layer of your study area. So let me make it hollow so as to see the DM files clearly. I want to extract or clip out my study area. So just go to Arc Toolbox, then go to Special Analysis Tools, then go to Extraction, then Extract by Mask. The input raster must be the DM of the Ethiopia. The input raster or feature mask data is the study area. Then the output raster means the path or the folder that you are going to save your results. So let me accept the default value as well. Then OK. Extract by mask has been done. So I don't want this the largest data. So let me remove. So this is the DM of the study area. So a couple of certain pre-process stages must be done in order to calculate the lineament density. So first go to Arc Toolbox, then Special Analysis Tools, then go to Surface, then go to Surface, then Hillshade. This is to create certain combinations for hillshade and to extract the lineaments or the line features. So the input raster must be the extracted D. This is a output raster, means the place where you want to save your output result. For this purpose, I will accept the default value as I did earlier. So the first one, the azimuth, I'll accept 315 and the altitude, which is 45. Okay, let me rename this 315 up to 45. Then I want to proceed for another completion. This is to extract features from each combination that is not visible in one combination and to catch up in another hillshade combinations. Then go to again hillshade, then the input raster must be the original dim, the extracted dim. Let me make this one to 200 and the altitude must be, let me make the altitude to 15. Okay, the altitude will increase and the azimuth will decrease in the next combination of hillshade computing. Then click OK. Perfect. The second combination of hillshade has been successfully computed. Then I will rename this as 200 to 15 and Let me proceed to the next hillshade combination. The input raster must be the extractor DM, and this azimuth will decrease rapidly from 200 to 100, and the altitude must be increased to 16. Then OK. Okay, the third combination of hillshade has been computed successfully. Then let me rename this to 100 to 16. Now the final hillshade combination will be computed. Then click again to hillshade. Then go to the input raster must be the extractor DM or the original DM. The azimuth is decreased rapidly from 200 to 100 to from 100 to 15, and the altitude will increase rapidly from 60 to 90. Then, as usual, click OK. Okay, great. This is the final hillshade map combination, which is 50 azimuth to 90 altitude. Okay. Then, in order to compute the lineament density, first I will identify the lineament features. So, in order to identify this, first these lines, I will create the shape files, the line shape files, and digitize from each combinations. Then go to ArcGIS. So let me go to D on my folder and create line shape files. Then go to there. Go to YouTube. Okay. So let me go to this. And let me create a new folder, which is lineament density lineament. This is a folder. Under the folder, I will create shape files. Shape file. Okay. New shape file. This is obviously lineament. The name must be lineament, and the feature type must be polyline. Let me this to let me edit the coordinate systems to WGS 1984. Okay. So this, as you can see, the line feature has been appeared here. Then I will directly go to editor, click on lineament, continue. Then go this hide lineament, select the construction tool, select line. Then let me uncheck all three combinations and digitize all possible lines. So digitize from this, yeah, all possible lines. Digitize carefully. Okay, let me change the colors to red. Yes. Yes. And check the second one, which is not catch up by the first. Okay. Okay, great. Now the third one. Third one, here it is. Yes. It's the final one. The final one. All possible lineament lines. We have successfully digitized all possible lines. Then go to editor again and click on stop editing. Then save edits. Now all the pre-process steps has been computed for lineament density mapping. In order to map linear density, first we have to identify these linear features. In order to identify these linear features, we have to compute a hillshade map with different azimuth and altitude combinations. For each azimuth and altitude combinations, we have identified the lineament features. So after we have already digitized the lineament features, then we are going to the next steps for lineament density maps. Then go to ArcGIS, then spatial analysis, then go to density, then line density, then the input feature. The input polyline feature must be obviously the lineament, the digitized lineament line features. So the population field leave as it is. The output raster must be the place or the path or the folder that you are going to save your output results. Just click OK. Successfully computed. As you can see here, the computation has been made in a rectangular basis by taking these reference features. So I will I want only my study area. Then in order to get my study area line density maps only, I will go to extraction tools, extract by mask. The input raster must be the line density. The input raster mask data must be the study area. Then okay. Yeah, perfect. This is the lineament density. Right click on lineament density and go to properties. So let us make some amendments on symbology, classify, for example, apply. Okay. So let us change the symbology. Yes, perfect. So you can uncheck these lineament features. Then this is the lineament density. The red one is the higher lineament density or the concentration of lineament density, which is responsible for some hydrological processes or an indication for example, the groundwater level indication or for flood susceptibility preparation and mapping. So the red, the one is the concentration of density, and the ones which is in a green color is the lowest density map or lowest density maps. So this is a linear. Let me make this to lineament. Lineament. When a map is fully recognized or understandable by end users, we always make to a layout, then go to layout view, then go to file, page and print setup, select this to landscape, then okay, as you can see here. Yes. Now let me insert some map elements. First, legend. Next. Okay. What is left here is that let me insert another arrow. You can select here this one and put here. Yes. Okay, what is remaining? Another scale bar. Let me select this one or select this one as you want. Based on your interest, let me put here. As you can see, the unit of measurement is miles, so let me change it to kilometers. Right click on this legend and division units, select kilometers, and the level, change the level to km, apply. Okay, this is legend. Okay, what is remaining? Scale bar. Okay, good, excellent. So let me right click on this data frame and add grid. Next, let me make this to this. Okay, next, and finish, apply. Okay, let me check the coordinate systems. So what is remaining is that make this to vertical and increase the number of fonts. Yeah, excellent. Now let me insert title, lineament density map. Let me right click and change the symbology to Ramond or as you want to tune it, for example. Okay, apply. Okay, let me put here. Go to file and export map. Then select the destination folder. For example, let me choose this to my folder. lineament density map. You can export as JPG or PDF or PNG as you want, but let me save as JPG. Okay, export completed. So let us open the JPG map, line density map. A great map has been produced. Therefore, this is a method how you can map lineament density by creating and digitizing lineament features from digital elevation models. So this is what we have today. Thank you for watching.